In this video, I am going to give you an introduction into this new model by Migel Tissera, which is called as Tess. Tess M was trained on G34 billion 200K base model, but the journey is not an easy one. And this model, Tess M version 1.3, has evolved quite a lot over the last few months. Let me give you a quick overview by the researcher, and that story, in fact, is a learning in itself. So, Miguel started with TESS version 1.0. TESS version 1.0 was trained on Lima principles. Lima stands for less is more for alignment, and that is a research paper by Meta AI. Miguel curated a data set of very high quality 4,500 samples generated by GPT-4 with Orca and Tree of Thought system prompts. The Tree of Thought or TOT system prompt was designed after he read the paper Tree of Thought's Deliberate Problem Solving with Large Language Models, and I have done a video on it and you can search it on my channels. TOT was a research done by the researchers from Princeton and Google DeepMind. Okay, once version 1.0 was there, he improved it by releasing test version 1.1. In version 1.1, Miguel added the Synth IA version 1.3 dataset to the test version 1.0 dataset, and now the sample of test 1.1 dataset was 125K samples. It He also trained the model with QLoRa for two epochs, but with one major difference to all of his training runs that he had done before. Then he read the Orca 2 paper, Orca 2, teaching small language models how to reason by Microsoft Research, and then he ran an experiment there. What he did was to train the model only with instruction and response, ignoring the system message. But then at an inference time, he added back the system message. Okay, now then he moved on to test version 1.2 and re-added the system context, keeping the data set the same as test version 1.1. And then he trained the model with QLoRa for two epochs. The model worked fine, but some of the annoying things from the Synth IA version 1.3 dataset started showing up. Now, he improved it a lot by doing a lot of stuff there, and also he tried to remove the contamination in that data set which I just mentioned, and then he sorted all of those issues and came up with test version 1.3, which I'll be showing you how you can locally install on Windows in this video. So for test M version 1.3, he trained the G 34 billion 200K base with QLoRa for three epochs, and the resulting models are amazing. He has tested the test M version 1.3 for up to 16K context window, and it does present with slight repetition around 16K context length. So that is a brief overview of it, and I'll drop the link to that story from Substack by Miguel in the video's description, plus also the Hugging Face model card so that you can read further along. Now let's go back to our installation of this model. Now, the tool which I'm going to use for this is called as LM Studio. If you are not aware of what LM Studio is simply a tool to install and run the quantized versions of LLMs locally, and I have done another video on it, which I'll drop the link in video's description. So first thing you need to do is to go to the home page, just write test and enter, and then you'll be presented with some of the results like this. And from this, I have just selected this second last one, the block test M version 1.3, and clicked on download from here. And as you can see, download is already in progress. So I just did it before, and as we were speaking, it's done. I'll just clear this one which I did previously. Now the model has been downloaded. Make sure you have 30 gig plus RAM because it's quite a huge model even in the quantized form. The model format is GGUF, which is the latest one. Okay, now just to quickly show you where the file is, you can come here, but you can see it is not there. There is a bug in LM Studio, so if you download a second model, then it doesn't show here. You just have to close this and start it again, and it will show. Let me do that quickly. So I have stopped and started this LM Studio again. Now click on this folder again, and there you go. You can see this model here now. In order to use it, click on these three dots In the middle, just select this model and it is going to load. And on the top left, it is going to show you your memory usage. So you can see as the model is loading, the memory will start creeping up quite rapidly and significantly. It is quite memory intensive in my experiment so far. Let's wait for it to load fully and then we will start playing with it. Okay, the model is loaded and I'm using the least quantized version one Q2. So I'm don't expect the quality of responses to be very high, but let's play with it. So the first thing I'm going to ask it, what is the capital of Australia? Let's see if it is geography aware or not. It is processing it. And remember, it's a quantized version and the very low quality quantization Q2. So let's see what it does here. Model has returned the response and which is spot on. It was able to deduct that it is Canberra, which is nice. And now let's ask it a reasoning question. So in this question, as is the case with the other videos which I have done, I'm asking it in 1 year, yellow paint fades and becomes a white color. In my house, in one room, one wall is yellow and rest of the walls are white. Should I paint the yellow wall as white now or wait for 1 year so that it fades into white? So let's see what sort of reasoning the model comes up. It is processing and I have noticed that it is taking a bit of a time even with the quantized version. So let's see how long does it take. So the model has returned the response and it is quite a compact but really nice one. So it is saying if you want the wall to be white immediately, then you should go ahead and paint over the yellow wall with white paint. This will ensure consistency, which is correct. But if you don't mind waiting for 1 year, you can let the yellow paint fade into white. And then it is giving you a warning that the rate of fading can vary depending on factors such as exposure to sunlight. So spot on. Really nice answer. And one is gets amazed that even this very low quality with this low quality quantization, the response is so spot on. Okay, now let's ask it one more question. So I'm asking it how to climb the K2 mountain in Pakistan. So let's see what it comes up. So because it's a how to question, so and K2 is quite a challenging one, so I'm expecting the model to give us some prerequisites, then a step-by-step instruction as how to do it. So let's see what it comes up. As you can see, model has started spewing out the result, and which is quite nice. You can see it has started with just describing what K2 is and then reiterating that it is quite challenging endeavor which requires extensive training, experience, and lot of physical mental preparation. And once that's out of the way, it is giving you step-by-step instructions with some of the prerequisites, how to prepare essential equipment, and so on and so forth. And then it is still printing it out because, as you know, um, it is just on my local system, so it is quite slow. But just imagine. Uh, this is the result from the contest run. Just imagine the full-blown model on a beefy system, and sky is the limit. So very impressed by the quality of this model. Do try it out if you are thinking of employing any LLM and let me know how is your experience. And I hope that you enjoyed it. If you like the content, please consider subscribing to the channel. Thank you very much.